Welcome to Highfinder Expo Highlights. Today with Lari Temonen from Sumitomo. And Lari, you came to the expo with an entire ecosystem. Tell us, what do we see here?
Yeah, so this is our way of visualizing the ecosystem for decarbonization and then different components of it. So you can see here that it's quite well connected, and now we could focus on three process flows here to describe those better.
So it's about carbon capture, and I think it's nice to say everything is connected. Now, when you look at this, so it's over there you have transportation and industries obviously using energy.
Yeah.
On the other side I see non-recyclable biomass, waste fractions. Where do you come in? What do you do of all these steps?
Yeah, so if we start with the gasification processes, so the idea there is that we have non-recyclable biomass and waste fractions. So we bring a bit the circular economy also into play. So we can gasify those into syngas, which contains hydrogen and carbon, and then we can synthesize those into different end products, including kerosene and renewable methanol, which can then be used by, for example, the aviation sector and shipping industries, so they can have renewable fuels.
Okay, so that's a basically path from how we get from that biomass, make it gas, and then get all kinds of fuels from there.
Exactly,
Hydrogen being somewhere on the way. Okay, and what other? This is one loop. What other loop do we see here?
Well, then we could describe this energy storage loop here. So we have variable renewable power, so solar and wind, which are not always, sun is not shining, wind is not blowing.
Variable renewable energy.
Yes, exactly.
Okay.
And then we have our long duration energy storage solution based on liquid air.
Liquid air?
Liquid air, yeah. So
okay, you compress air, okay.
We take the excess renewables, and then when there is not sunshine or wind blowing, we can support the grid by producing electricity, or we can directly for the industries produce green power 24/7.
So just say this is long duration energy storage by compressing air.
Yeah. We are using clean air to store power.
So you just compressed air.
Yeah.
Okay. And what about using it for electrolysis directly?
Yeah, this way we can balance the electrolysis, so we can run those like also in the times when there is no sun or wind energy available.
All right. Okay. And with that you generate hydrogen, which obviously goes into your synthesis for fuels again.
Yeah, so in the synthesis we can either get the feedstock from gasification, or then we can get it from electrolysis and carbon capture, which can supply the same hydrogen and CO2.
Okay, so now you said something interesting, carbon capture. So now we've understood this loop. What are we seeing down here? And I see you have some acronyms now.
Yeah, so here we are seeing three SFW carbon capture technologies. So there is the Oxy Plus.
What does SFW stand for?
That's our company name in short form, so Sumitomo Foster Wheeler SFW.
All right, okay, that's your company name. Okay, yeah. And Oxy Plus is the
brand for this carbon capture technology.
Okay.
So it's based on Oxy fuel.
All right.
And then you see that all of our technologies have this plus, which is sort of connecting those together.
Okay, so what is happening here? Here we're getting the gas from the gasification? Oh no, not the gas from what are you? Where's the carbon coming in here? I can see the emissions coming in there, but where's that?
So this Oxy Plus is basically a biomass power plant. So we get this green stream, which is the non-recyclable biomass and waste fractions.
Yes.
And then we can get oxygen either from, we can produce it, or if you have electrolyzers, those actually produce quite high volumes of oxygen. So we can take that oxygen stream and run our carbon capture process.
Understood. So essentially for this you need oxygen and you need those biomass, and then that input goes in over here. What is this SFW HPC? Well, SFW, obviously your company name, I learned that. the HPC and the Cal Plus. What is that?
Okay, so these are then the two post-combustion capture technologies. So the first one is hot potassium carbonate, and we can take emissions from any type of source, and then we can capture the carbon out of that. And then we have the calcium looping, which is another technology based on calcium oxide.
Okay.
So that can also absorb the CO2, so either from power generation or from heavy industries. And then that CO2 can be either stored permanently, or we can utilize it in the synthesis applications where we can again create renewable fuels.
Okay, so that means the synthesis is where the CO2 is put in there, and this is where it's actually stored in some mines also.
Yes.
Wow, okay. That's a hell of a picture. Thank you very much, Larry, for taking us through that. Now we understand a little bit more about the carbon capture process and how all is interconnected, and how Sumitomo can also help to do that. Well, thank you very much for watching. I hope you enjoyed it. Larry?
Okay, thank you.
Absolute pleasure. Thank you.
Thank you.
Bye.